All right, so while we are thinking about how we want to start part B, I just want to remind you of our helpful tips that we wrote down yesterday. Okay, so if you're not sure what to do, we wrote down a list of strategies so that we could see what to do if we got stuck. Okay, so I'm going to go through those right now. So the first thing is try to rewrite with sign and sign. We're going to substitute with identities. We might have to factor, get the least common denominator and combine fractions, or multiply by the conjugate. So yesterday we did a lot with the rewriting with sine and cosine and the substituting with IDs. So today I'm going to show you some of these as well. Okay? And again, there's more than one way to do this. Okay, we're just going to go through a few things so you get exposed to different methods. So the first thing that you're going to do is choose which side is more complicated. Okay, what do you guys think is more complicated, the left or the right? Yeah. Okay, if you have a fraction, you're always going to have more things to do with that, and this is sine to the third versus here where you wouldn't have anything to plug in. So we're going to start. This is sine cubed of mu over 1 plus the cosine of mu. And then I want you to write these in a column, okay? So like even when you're doing your homework, I want to see it in a column, okay? It makes it look a lot neater. It's easier for me to grade that. So this is given. This is your left-hand side. So I just went over that list of different things that you can try. The one we're going to do for this is we're going to multiply by the conjugate. We can't substitute anything in identity-wise. Everything's in terms of sine and cosine. So when you have 1 plus the cosine in the denominator, a good thing to do here would be to multiply by your conjugate. Just going to separate those. So when you do that, you do have to show the step. Okay, and I know that sometimes that can be a little tedious of rewriting those things out. Okay, but what we're doing is we're just developing our reasoning and our proof and presenting our argument in a logical manner here. And then your reason is just going to be what we're doing in this case. So you're multiplying by the conjugate. Okay, and that's enough. You don't have to say by the denominator. You can just say multiply by your conjugate here. Okay, and then keep in mind when you are multiplying here, you're going to be foiling in the denominator. So 1 plus cosine, 1 minus cosine. This is something we saw in the preview worksheet. So when you FOIL, 1 times 1 is 1. Here you get positive cosine, negative cosine. Those are going to cancel. And then a positive times a negative is going to be the cosine squared. Now, sometimes when you're multiplying, it's actually better if you keep this as a product. So sometimes you're going to find it useful not to distribute. Okay, and one clue for that is remember that you are trying to get to this. See how you have 1 minus the cosine of mu in the final answer, and now that's what you have here? Okay, so what we're going to try to do is we're going to try to make the rest of it into the sign. So you can use that to help you when you're not sure where to go. Okay, and then for this, you can either put like multiply or simplify. Okay, put multiply fractions. You can put simplify, that is fine too. There are some steps where I'll accept multiple things. All right, do you guys see what we're going to do next? What? Yep, we're going to plug in an identity. I also wrote those 3 identities on the board because those are the most common ones you're going to see. If you have 1 minus the cosine squared, you can rewrite that as the sine squared. Okay, the numerator is going to stay the same for now. And I know that sometimes our brains work faster than our pencil. Okay, so sometimes we just have to slow it down so we can remember how we're getting to the final. And that is our Pythagorean identity. So 1 minus the cosine squared is going to equal the sine squared. That's why we're allowed to substitute. And when you have multiplication here and division, you can divide these. Sine cubed divided by sine squared is just going to be what? Sine. So we have the sine of mu times 1 minus the cosine of mu. Okay, when these match, you know that you are done. And don't forget your reason. So all we did is divide. Okay, we divided sine cubed by sine squared. Okay, once you get that other side, you are good.
When it's a Pythagorean identity, like reciprocal identity, can you just write that, or do you have to write?
So the only one that you have to write it out for are the Pythagorean identities. Okay, but for the reciprocal, those are fine. You can just write reciprocal. But anytime it's a Pythagorean, because you have so many different ones and those are new to us, I want you to write what you're substituting in.
You don't have to like this side equals this side kind of thing, just the check work.
Yes. Yep. So your last step should always be this other side.
Yes, but we don't have to like show that below.
Right.
Okay.
Right. Like put the equal to.
Exactly.
You can't. So remember what we talked about yesterday is if you are trying to prove a trig identity, you can't perform any operations to both sides. A lot of times one side is going to be more complicated and the other side is going to be simple. There are ways where you can kind of get around that. This one wouldn't, these two wouldn't really be good examples of that because it would be really hard to go from this step to this step. It just depends on what it is.
I would like if I wanted to like this time to the second step, and then also this time.
Oh, like this?
Yeah.
Yeah, you could distribute
And
then make this the sine squared and then divide each of them. Yeah, but that wouldn't be working with both sides. Sorry, I thought you meant like this side here. So once you choose a side, there are different ways that you could do this. So yeah, if you wanted to distribute this, and then you would still want to convert this into the sine squared, and then you'd end up dividing this and your expression here by the sine squared, okay? And then you would have to do factoring in the last step, but that would be possible, yes. Okay, now one like part C, really, you have options on both sides. So if you were doing part C on your own, okay, I would let you choose either side that you wanted to, okay, but I want to expose you to some different ways of thinking. And so we're going to start with the right-hand side on this, and I'm just going to give you some other strategies. Okay, again, there's more than one way to do these, but I want to make sure that you've seen some different methods so that you can apply them yourself, okay? Okay, so now we're going to start with the right-hand side. So even from this step, even if some of you started with this one on your own, some of you might FOIL. Do not just square it. This is not the secant squared minus the tangent squared. You'd have to expand and then FOIL, okay? And that would be an option, but I'm going to show you a different way. We're going to start by writing out the reciprocal identities. Okay, so 1 over the cosine. Okay, that doesn't mean if you tried something else that you're wrong. I just want to show you some different ways. Okay, so we use two reciprocal identities there, one over the cosine and then the sine over the cosine. Okay, then we are going to subtract the fractions because they have a common denominator. Okay, so we have 1 minus the sine of x over the cosine of x. And I can see here that I need to end up with 1 minus the sine of x on the top. I am getting closer to that now that I've performed that step. And when you have a square with a fraction, you can distribute that exponent or the power. Okay, so we're going to distribute the exponent. Okay, sometimes with these, all you need to do is rewrite something in a different way in order for you to see what the cancellation is. So that's going to be something I'm going to show you in this example. Also, I can see here I want 1 plus the sine in the bottom. So if I have the cosine squared, okay, that lets me know that I can use the Pythagorean identity. I'm also going to expand the numerator, or you can say rewrite as a product. And we're going to use the Pythagorean identity as well. Okay, so sometimes you are just going to rewrite this. So 1 minus the sine squared, I just want you to write it as 1 minus the sine of x times 1 minus the sine of x. Okay, and then we know the Pythagorean identity is 1 minus the sine squared of x. And remember, we're trying to get here. So I know I'm going to have to cancel something out, okay, but there are mathematically legal ways to do that. There are illegal ways to do that. So sometimes when people get here, they want to cancel out the ones and they want to cancel out one of the signs. Okay, you're not allowed to do that because of your order of operations, right? You have this on the bottom here. You could only cancel out 1 minus sine squared with 1 minus sine squared. And then also, if you did cancel those out, a lot of times you would just rewrite that as 1 minus the sine of x. Remember, on the bottom, I need 1 plus the sine of x. So one thing that we did on that preview worksheet is we practiced doing factoring with this. So if you have 1 minus the sine squared, do you guys think that you could factor that? So the numerator is going to stay the same. And we're going to factor the denominator. Okay, so when some of you are having trouble like factoring on the preview worksheet, one thing I did to try to help is I said, instead of 1 minus sine squared of x, why don't you just think of it as 1 minus x squared? Could you factor it then? Because this is just the difference of two squares, right? So this would be 1 minus x and 1 plus x. Wouldn't that factor back to this? It's just instead of x, we have the sine of x. Okay, so when you factor this, you have 1 plus the sine of x times 1 minus the sine of x. And now you can divide. Okay, so now you can cancel those out. And we did it. Okay, so now we've seen a little bit of everything. Multiplying by the conjugate. We have those different IDs. We've subtracted fractions. Okay, we've done factoring. Okay, so you've seen a little bit of everything that is on that list. Okay, so the 7.1 homework is due tomorrow. Okay, it's the one that you started yesterday. I'm going to put that up on the board for you.